अच्छा we're starting. We will start with chapter 1 again, which is मेरे recording issue हुआ था. मेरी आवाज आ रही है? You guys can see the screen, right?
Yes.
अच्छा, we'll start with chapter 1, which is entropy and कहाँ से खुलेगा? ठीक है, this one. तो entropy से start करें. अच्छा, now the thing is कि let's start. अच्छा, this is chemical energetics. So the first part and the very first part, that is that you have to understand what entropy is. So entropy is it's the measure of disorder of a system. It's the number of different microstates that a system can have, which basically means that if you have a room, how many different ways can your room get dirty, right? So it's the measure of disorder of a system. Okay, that is simply what entropy is. It literally means disorder. It has a symbol, and that's S. If you're talking about standard entropies, then it's going to have a naught on top of it. So and the unit for entropy is joules per Kelvin per mole. Okay, that's the unit for entropy. Now, now the first thing is there is things that have low entropy. That means less disorder. And there are things that have high entropy, and that literally means more disordered. Okay, remember, entropy is, it just simply means disorder. So there's low entropy, there's high entropy, less disorder, there's more disorder. ठीक है, less disorder, and you've got stuff that has more disorder, right? So things, they move from low entropy to high entropy states, and they come back as well. So what we're really interested in is the change in entropy. So that is known as delta S. And if you go from low disorder to high disorder, you go from low entropy to high entropy, you're gaining disorder. So that is delta S positive. That means there's an increase in disorder. Things become more disordered. ठीक है, an example of a low entropy state is that you've got a deck of cards, uh, very neatly ordered. So there's a deck of card, and all the cards, I mean, just like I mean, if you buy a new deck of cards, all of them are lined up properly, from one, two, three, four, and so on. So there's a deck of cards that's very neatly ordered, and there's a deck of card high entropy status. There's a deck of card that is shuffled. That is thoroughly shuffled. So that's a very disordered state. Because that is delta S positive. You go from less disorder to more disorder. And you can obviously come back as well. You can come back from a high entropy state to low entropy state. You've got a deck of cards, and that's very disordered, and you can arrange them. You can sort of start arranging the cards in the proper order back again. So that is delta S negative. You're losing disorder. So there's a decrease in disorder. ठीक है, Qasim, Minal, Isaac, is this clear? Sana, is this clear?
Yes.
Okay, so I mean, so just the basic idea what entropy is. I mean, you should know if you have a neat and tidy room, and that's low entropy. You've got a very messy room, that is high entropy. So there is delta S positive. Your neat and tidy room goes to a messy room, so the disorder increases. That's delta S positive. You clean up your room, you go into a more tidier state. That's a decrease in disorder. That's delta S negative. And so which one out of the two is easier to achieve? Delta S positive or delta S negative? Yoga, Minil, which one is easier? Isaac, Qasim? Minil क्या होगा? कौन सा? Which one is easier? Positive or negative? Anyone? Qasim? Message किया?
Negative.
नहीं, उसका सोचो ना कि you've got a neat and tidy room and there's a very messy room. Which direction is easier? Neat and tidy,
Positive.
yeah, positive, right? Positive is easier, na? कि it's easier to shuffle the cards. I mean, you don't really have to. I mean, imagine you've got a deck of cards, right? That's very neatly arranged. It's very easy to shuffle them. I mean, do anything and they're going to get shuffled, right? But if you've got a shuffled deck of cards, you have to make a lot of effort to actually get them back into order, right? So delta S positive, that's easy, right? And vice versa, delta S negative is that is going to be difficult. I mean, this one is going to be difficult. You've got a messy room. It's difficult to actually go into or make it into a neat and tidy room. You got a neat and tidy room. You don't have to do any special effort. It just becomes messy on its own. ठीक है? ये clear है? Is this clear? Qasim, Minal, Sana, is this clear? Isaac, is this clear?
Yes.
Yes.
This is a change in disorder, right? So remember, there's a universal law that things go from low disorder to high disorder. Uh, you've got a house. That house is going to go towards disorder anyways. I mean, you make a new house, which is very neat and tidy. It's going to become disordered. Things will break down, okay, and they will become messy. You've got a car, you buy a new car, that new car will eventually break down. It's going to go towards disorder. The opposite is very, very difficult. You buy an old car, which is very disordered, it's not going to become a new car automatic, at least not automatically. Okay, that's not going to happen. Uh, but if you buy a new car, the new car, you don't have to do any special effort. It just becomes, I mean, it starts breaking down. It starts going into high entropy state. So the universe loves high entropy states. Okay, so high entropy states are considered to be more stable. They are, so high entropy states, remember this, these are your more stable states. I mean, for example, you buy an old car, it's going to remain old. I mean, if it's an old broken down car with a very high entropy, a lot of disorder, it's just going to maintain its state. Or the best thing that could happen is it's going to become even more disordered. It's going to gain even more entropy, right? So more stable states are high entropy states, whereas low entropy states are very unstable states. They Things don't like being in low entropy states. Okay, you put on new clothes, your new clothes, I mean, they're going to gain entropy. They will gain entropy automatically. So high entropy states are more stable states. These are your low energy states. That means you don't spend a lot of energy gaining those states. So these are your low energy states. The other ones are like really high energy states. ठीक है, so going back into an ordered state that requires a lot of energy. So those are all your high energy states, and these are your. I mean, the high entropy states also have high probability as well. That's why things like to gain disorder. They are high probability states or highly probable, and your low entropy states are they have low probability. Things simply don't like. I mean, they don't like low probability states. And there's a reason for that. It all comes down to probability. I mean, if there is a deck of cards, so how many different ways? I mean, there's only one way in which a deck of card. I mean, let's say there's only one way in which a deck of cards is neatly arranged or arranged in an orderly way. So the number of ways in which a deck of cards is going to be arranged in a disorderly way, that's infinite, right? There are infinite possible ways to have a disordered deck of cards. I mean, it's literally very close to infinite. So infinite possible ways to have a disordered deck of cards. Okay, so there's a reason for this that why does the universe love high entropy states? And the reason is that there are so many high entropy states. I mean, you have a house, I mean, you have a car. There's only one way in which the car works in the right way. How many ways can it break down? There are like infinite possible ways in which your car would break down. So so breaking down has a very high probability because there are infinite possible ways in which that could happen. Your messy room has infinite possibilities because the infinite possible ways you can make your room messy. I mean, they're literally infinite possibilities. You can do infinite things, and your room is going to turn messy. How can your room? I mean, if you want to make your room clean, there's just very few ways. I mean, so so low entropy states have a very low probability, and high entropy states have a very high, inf almost a probability that's close to one. ठीक है? Is this concept clear? Middle clear? Isaac, is this clear?
Yes.
Qasim. ठीक है? So just remember that delta is positive. I mean, there's no law that delta is has to be positive, but it's just that delta is positive. High entropy states are highly probable states. So the first thing is you have to learn how to predict the sign of delta S, which we have already discussed. Positive means gain of disorder, negative means a loss of disorder. So पहले तो I'm just going to pick some random examples. For example, I've got um what do we call it? The one I gave you. It's so I've got a messy room and I've got a neat and tidy room. So बताओ कि what is happening over here? If you go from this to this, what happened? Delta is negative or delta is positive? Qasim, middle, Isaac. मिडिल क्या हुआ है? इब्राहिम कुछ समझ आया इसका?
Can you repeat?
नहीं बता okay, but going from a messy room to a neat and tidy room, is that delta as negative or delta as positive? ठीक है Ishaq, that is negative. Entropy is decreasing. ठीक है, this was high entropy. And the other one is, the other one is low entropy. ठीक है, so remember the first thing is you have to predict the sign of delta S. ठीक है, so um, there'll all be different situations, and you've got I mean, pretty much, okay, we're going to come to chemical reactions. How do you figure out whether this is chemical reactions, about chemical reactions? How do you figure out whether a chemical reaction is gaining entropy or losing entropy? The first one is it's a change of state. You're going to look at change of state. And remember, whenever there's a change of state, what happens is that if you go from solid and you go to liquid and then you go to gas. Now, solids are highly ordered states. So that means there is low entropy, very low entropy. They're very organized, right? Gases are highly disordered. So that means they have very high entropy, right? Okay, and so solids are that you have particles, and those particles are very neatly arranged, so they're very organized and ordered, right? So it's a regular arrangement of particles. Let me draw this. So it's kind of a regular arrangement of particles. Liquids are kind of the same, except that they are slightly more disordered because the particles are kind of energetic. And since they are energetic, they're able to move around and they're able to slide around and they kind of are loosely packed. So there's slightly lesser attraction or the particles are more energetic, which is why, and these particles are all moving around. So there's slightly more disorder. So these are all sliding in liquids. Okay. So this is slightly more disordered. And when it comes to gases, they are like very disordered. So you've got gas particles, they're going to be very far away and they will be highly disordered. Okay, they'll be randomly going around in random directions, completely random directions. Someone going left, someone's going. Okay, so they're all over the place. So that's high entropy, that's low entropy. ये clear है? Ibrahim, Qasim, Minal. Sana,
Yes,
is this clear?
Yes, sir.
Okay, so you got solid, liquid, and gases, and now you also have to understand that uh, this is delta S positive. This one is delta S positive, and this one also happens to be delta S positive, right? Except that the two delta S positives, they're not equivalent. Over here, there's very little difference. I mean, although it is delta S positive, but there's less difference. And on the other one, that is also delta S positive. I mean, there's a change that's happening, but there the difference in entropy is huge. So that's a huge difference in. So always remember when it comes to chemical reactions, solids and liquids, uh, they're kind of almost the same. I mean, not exactly the same. There is obviously a difference in disorder, but it's not that huge. But when it comes to gas, the difference in disorder is huge, right? TK, is this clear?
Yes.
TK, Isaac, Ibrahim, Qasim, Sana, is this clear?
Yes, sir.
Yes.
Okay, so I'm going to plot the entropy, the change in entropy of how water is going to behave. So for example, we're starting at, let's say, I'm starting at minus 200. Let's say this is minus 200. This is minus 100. This is 0. Then you have 100, then 200, and then I shouldn't have started with, okay, anyways, 300 and then 400 and 500. Okay. And then remember that's in Kelvins. So 0 centigrade is, I said minus 200 to 1. Let me change that to centigrade. Kelvin doesn't have a minus scale. I say anyway, so first thing, it's ice at up till 0, right? So it's ice at, let's say, minus 10, and it's also ice at minus 200. I said between the two states, is there a huge difference in entropy or is it almost the same? I mean, if you look at ice at minus 50 degrees centigrade or minus 10 degrees centigrade or minus 5 degrees centigrade or at minus 250 degrees centigrade, ice looks exactly like ice, right? That means the disorder is almost exactly the same, right? ये बात clear है? Is this clear?
Yes,
Yes.
sir.
I said but there's going to be just a very tiny amount. I mean, this is a very, very tiny amount of change in disorder. ठीक है? The entropy will increase because temperature increases. So some of the particles might get disordered, but overall, not that much of a difference, right? So little change in ice, in arrangement of ice. But obviously, kinetic energy is increasing, so maybe some of the particles might get disordered. So the crystal lattice might very, very slightly get disturbed. I said, but anyways, move to the next part. At 0 degrees centigrade, it melts. Then all of a sudden, what you see is it turns into liquid, right? At 0 degrees centigrade. So it changes into liquid, right? And you see a change in disorder. And then it is kind of, it's going to remain constant. I mean, if you look at water, liquid water at 10, or liquid water at 50, or liquid water at 70 degrees centigrade, it kind of still looks like liquid water, right? I mean, if I give you 3 glasses of water, you won't be able to tell the difference. That means the disorder is not really changing a lot. TK, is this clear? Although there would be some slight increase in disorder at 70 compared to 10, but the difference would be very, very less. TK, is this clear?
Yes,
Yes.
sir.
अच्छा, फिर at 100, what happens is there's a huge drastic change. ठीक है? I mean, if you've seen boiling water, the bubbles start boiling and there's this huge dramatic increase in disorder. And after that point, it doesn't remain constant because it just shoots up. Steam at 200 and steam at 400, right? I mean, if you look at steam at 200 and steam at 2000 degrees centigrade, they're not going to be exactly the same. The arrangement is not going to be exactly the same. The amount of disorder that they're going to have, it's not going to be exactly the same. Actually, it's not even going to be close. It's going to be steam at 200 and steam at 2000. Steam at 2000 is extremely destructive. It's got a lot of disorder inside it, right? Uh, because the thing with steam is that it expands. So ये बस last बात करते हैं कि steam or gas, they expand. So liquid when they are liquid, they kind of remain exactly the same. When they're ice, they kind of remain exactly the same. But when they are gases, they increase with temperature. So steam gas expands with temperature, and their disorder increases, right? In the case of water at 70, water at 10 degrees centigrade, both of them will almost contain the same disorder. I mean, the glass will not blow up. It's nothing would happen. But in the case of steam, you've got a container that's got steam at 200 and you've got a steam at 2000. The 2001 is going to be very, very destructive, right? You clear about?
Yes, sir.
Yes.
Yeah, so first thing, remember gases have a lot of disorder compared to solids and liquids. Solids and liquids, they kind of have the same disorder. So the next thing is, it's I mean, point number two is this was one. So point number two is that delta S is going to be positive. So gases matter, right, in a chemical reaction. If there is an increase in gas molecules, and then you have delta S, which is going to be negative. This is when there's going to be a decrease in gas moles, right? So you got a chemical reaction and the gas molecules are increasing. For example, like fizzy drinks, TK, you've got carbonic acid, and as soon as you open the bottle cap, the dissolved carbon dioxide, it starts forming bubbles. So this one is liquid, this one is a gas, and this one is aqueous. Okay, so you look at this reaction. On one side, you have no moles of gas, 0 moles of gas. On the other side, you have 1 mole of gas. So all of a sudden, what has happened is if there's an increase in gas molecules, that is delta S positive. ठीक है, is this clear?
Yes, sir.
ठीक है, similarly, if there is a decrease in gas molecules, this is going to be delta S negative because यहाँ पे there are 3 moles of gas, and on the other side you have 2 moles of gas. So that is a decrease in gas molecules, and so the disorder will decrease. ठीक है, तो चलो ठीक है, यहाँ से कंटिन्यू करते हैं नेक्स्ट टाइम. ठीक है,
Okay, sir. Allah.
ओके एवरीवन, टेक केयर.